Hey, what's up? Today we're taking a look at a package you can't avoid if you want to become a data analyst or data scientist, Pandas. Nothing to do with the cute bear things. Pandas is all about data frames, not bamboos. These data frames allow you to store and manipulate data very efficiently, kind of like dplyr if you're a R user. Just like our Numpy video, Pandas is actually built on top of Numpy. This one might feel like the Lord of the Rings extended versions. But you don't mind if it is long, as long as it's good, right? Now don't say anything. So, what's the dealio with Pandas? Like I said, Pandas is based on a data frame object. A data frame feels a lot like a classic database table. So if you like SQL, you will like Pandas. Once your data is in a data frame, you can do all sorts of things with it. One of the things Pandas is great at is cleaning your data so that you can analyze it or put it through your machine learning algorithm safely. Pandas also has nice features when dealing with time series and time operations. And although Pandas is not a visualization library per se, it has some quick and dirty plotting features that can help you see what your data looks like. Here is a link to the Pandas website. Check it out, it's very well made. As usual, link in the video description. So, installing and importing Pandas. This section is going to remind you of my Numpy video. If you use Anaconda, Pandas is already installed. If you don't, tough luck. Or go to the Pandas website. Once installed, you can import Pandas like so. The convention is PD. Let's import Numpy too. It's the same price and it goes hand in hand with Pandas. So now we can get to the good part, how to build a data frame. There's a function for that. First, let's consider these 4 lists about 3 Pokemons, Charizard, Articuno, Tauros. We can put these lists in a dictionary. So we're basically building a dictionary of lists. You know about these 2 things because you've watched my 3rd video, right? I'm going to call that dictionary my data. It's going to hold the name of the Pokemons, their health points, their attack points, and whether they're legendary or not. Let's also use the keys method to store the headers for our data in a variable called myColumn. We can now use the data frame function. We're going to call our data frame df underscore pk for Pokemon, pd for Pandas, dot data frame, capital D, capital F. And we're going to pass 2 arguments. The first one is data. That's going to be our dictionary. The second one is the columns. So that's going to be my columns. Nice little data frame. Well, let's check if it's really a data frame. Using the type function. Yep, it's a data frame. With the index attribute, you can access the index of the data frame. Let's try it out. We can see that the index of the data frame is 0, 1, 2 because 3 is exclusive. This index was automatically assigned, but obviously you can set your own. For instance, if we want to make the names of the Pokemon the index, we just do it like so. I want the column to be name, and I want to replace my index, so I'm going to say in place equals true. So we can see that now the names of our Pokemons are the index. Please note that Pandas doesn't require indexes to be unique, but obviously it's better if it's the case. You can access a column of your data frame like this. Data frame, brackets, name of your column, for instance, legendary. Let's check the type of that thing. This thing is called a series. I'm not going to dwell on this, but basically data frames are a collection of series. And series are kind of similar to Numpy arrays that we've seen in the previous video. So let's see how we can load data in Pandas. We're going to use 2 main datasets today, a real one and a made-up one. For the real one, I am using data that is everywhere nowadays. Daily coronavirus cases by country. I got it from the European Center for Disease Prevention and Control. Link in the video description. I downloaded that data in a CSV format and saved it in the folder of this Jupyter notebook. Here is the file name as a string. I can create my data frame that I'm going to call C19 for COVID-19 and use the function read CSV and pass as an argument my file name. That's it. There's a similar function for JSON files, so let's use it on our made-up dataset. They are called clickstream, which is about the web tracking data of a fictional e-commerce company. I'm going to call that data frame clickstream and use the function read Json. Let's also read another JSON file in a data frame that we'll use later, still as part of this e-commerce dataset. I'm going to create countries and use the same read JSON function. You now know how to load CSVs and JSON files, as well as generate your own data frames from scratch. Just so you know, there are other ways to get data. For instance, you can get it straight from a website, you can also scrape a website, and you can even connect your Jupyter straight to a database, and for instance, pass some SQL as a string to pull data and land it in a data frame. So now we can take a look at the data that we've just loaded. Pandas has a lot of functions to quickly understand the data. We can start with a function called head on our coronavirus dataset. This function shows you the top records of the data frame. The default is 5. And we can get a sense of what our coronavirus data looks like. There's a date column, the day of the month in the year, the number of cases, the number of deaths, the country in these 3 columns, and finally the population data of that country in 2018. The sample function does something similar, but instead of picking the top rows, it returns random rows. For instance, to look at our clickstream dataset, we get 3 rows picked at random. There's a cookie ID. As you probably know, cookies is how websites define a visitor. Some sort of session ID to define a visit of that visitor. A column that seems to be about the country the visitor is from. The name of the pages that they've seen, in what order, and a date column. The dtypes attribute works like the dtype attribute in Numpy. We can try it on our coronavirus data frame. It lists the columns and the data type of each column. For instance, day is an integer, but population is a float. This gives you similar results as the info function. The main difference is that it gives you the number of rows, as well as whether some values are null or not. Just like in Numpy, there's also a wide array of statistical functions that you can use. For instance, looking at just one column, the number of cases, I can get the mean. The describe method can also generate a useful report for quantitative columns. You see, it picked all the columns with numbers. Obviously, the mean of day or month doesn't make much sense, but here is the daily mean of cases, for instance, 152. You have the standard deviation, the minimum, you have the median, the max. It's nice and quick. The value counts method is very useful to find out what are the values in a certain column and how many there are. Let's say we're interested in the cookie ID column. You can see the values that that column is populated with and how often they appear in the data. So these two are the 2 most frequent ones with 4 occurrences. And remember, when I told you that you could generate visualizations very easily in Pandas, I can recycle the code above, .plot, .bar, and I get the same information, but displayed as a bar chart. Here are the 2 values with the most occurrences. Not super pretty, but very easy. And don't worry, we'll learn in the next session how to make nice graphs. Just like Numpy, Pandas allows you to index and filter your data kind of like lists. You can select rows and columns using implicit indexing. For instance, you write your data frame dot I for implicit, then lock, and then square brackets. 0 will return the first row. This is the row about Charizard, and here are Charizard stats. Because these data frames are in 2 dimensions, you can add another parameter. For instance, 1, 1, 3 returns the second row and columns 2 and 3. So this was implicit indexing, but you can also use explicit indexing with .lock. Here we are no longer using the integers, but the actual names of the index and the columns. So let's say we're interested in the torus index and only the legendary column. And it tells you that for the torus index, the legendary column is false. And again, just like we did with Numpy, I feel like I'm going to say that a lot today, you can also build and use masks to filter your data. So let's build a mask first. For e-commerce dataset, let's say we're only interested in confirmation pages, because this is how we define a transaction on the website. I get a column of trues and false, and we can use that mask like so. The data frame name, square brackets, and inside our mask of trues and false. I only get the records where we had the true in the column above, so only 2 rows here. And you can see that it's only confirmation pages. And just like in Numpy, you can also build more complex logic in these masks. For instance, for our coronavirus data frame, I'm going to use an AND. I'm only interested in records where the population of the country is less than 100 million, but is more than 10 million. You see, I get records for Afghanistan, for instance, because Afghanistan in the data has a population of 37 million. You can check my Numpy video if you want more mask examples. Pandas is also great at cleaning data. It is a crucial step in analytics and machine learning, and even if your data is not too crazy, because quite often you want your data to fit specifically your use case. So let's see how we can do that on our practice datasets. One thing you can do is get rid of columns you don't want. The method that you want is called drop. You're going to specify that you want to drop in place because you want to change the data frame, and the name of the columns you want to get rid of. For instance here, GeoID. So you can see that we no longer have that GeoID column. But this is Python, goddammit. So we can be smarter about it. You can create a list of columns that you want to drop. I'm calling that list no need. And using the drop method again, I'm going to say my columns are equal to no need. You can obviously create your own columns too. You just write the name of your data frame, followed by the name you want to give to your column. For instance, perch flag for me. And I'm going to build that column using the where function. And as I was saying, we're going to use page name as a way to define whether there was a purchase or not. If the page is confirmation, then I'm going to count that as a transaction, otherwise as nothing. My new column has been added at the end here. You can also split a column in two. Let's take a look at our cookie ID column. It seems to be made of 2 parts, separated by a dash. There seems to be some ID of the device that people are using, mobile, desktop, or tablet, on top of the actual cookie of the visitor. That's not great in terms of data management, so let's clean up this mess using string split. I'm going to create a new cookie column based on the existing cookie ID column. I'm going to use .str.split. I'm going to pass as argument the dash, because that's how the 2 values are separated. I'm also going to set the parameter expand to true, because I want to get 2 different columns, one for each of the items in cookie ID. And the second element, so using square brackets 1, is going to be that cookie ID. And similarly, in the device column, I'm going to recycle the code, but change that to 0 because the first element is the device. I'm going to drop my existing cookie ID column because I no longer need it, and display a sample of the data frame. 2 columns, one for the cookie and one for the device of that visitor. Quite often you will want to rename some of the columns. I, for one, have very specific taste in column names. So I'm building here a dictionary with the old column names as keys and my new column names as values. Then I can use the rename method and pass that dictionary as an argument. And again, I'm going to write in place equals true because I want to change the FC19. I'm much more comfortable with these column names. You can also alter a column's values too. So let's go through two examples. First, say I want capital letters instead for my cookies. I can use the string upper method. .str.upper. So now my cookies are nicely capitalized. Let's say now that I want more explicit names for my device. Again, I'm building a dictionary with lookup values. And for my device column, I'm going to use the map function and pass my dictionary as an argument. See, now I have more explicit names for the device. Now, nulls. A very frequent problems you have to deal with in analytics and machine learning. The isNA method in Pandas allows you to find out if you have null values or not. You write the name of your data frame .isNA. That returns a data frame of Boolean values. You can see a true here and a true here. Because I told you a long time ago that trues in Python are kind of like ones in the background, a cool trick is to do this, .sum. You get the list of your columns and the count of the nulls. So I can see that I have a null in country ID and I have one null in page name. So let's investigate a bit more to find out what we're going to do to these nulls. Because isNA returns a data frame of booleans, we can use it as a mask. I get one record where the country ID is null. Technically, it's NaN, which means not a number, which is a form of null. And we see that null is related to the PQR cookie. So let's check this guy out to see what we're going to do to him. We see that this cookie is related to country ID 2 on all of the other records. Using our domain knowledge of what a cookie is, we can safely assume that the country ID for all 4 records is equal to 2. So let's replace this null using another pandas function. My column is country ID, and that function is called fillNA. And in that case, I want to fill that NA with a 2 and pass on the parameter in place equals true. All good now. We can now move on to the second null, the one in page name. We've established that the page column is quite important because that's how we define a transaction. So what we might want to do here is actually delete the record altogether instead of running the risk of making a mistake on that column. There's a function for that too. And that method is called Droppin. As the subset parameter, I'm going to tell it to look at the column page name, and I'm going to set the in-place parameter to true. The JKL record with the null has disappeared. There's only one left. Sometimes you also want to change the data type of a column. Let's first display the data types of clickstream. And let's say, for instance, that I want my purchase flag to become a Boolean. And you're going to use the asType method. In that case, I want it to become a Boolean. My purchase flag column is now populated with false and true. So, now that our data is clean, we can aggregate it, order it, join it to other datasets, very much like you would do in SQL. First, let's see how to group data in Pandas. As a reminder, this is what our coronavirus data frame looks like. So let's say we don't really care about the date grain and we just want to aggregate the data at country level. Let's store that in a new data frame, df_grp for group. I'm using my coronavirus data frame and the method groupBy. As I was saying, I want to group by country name, and I'm going to add country population because I will want to use that column later on. And I'm going to specify that I don't want them to become index. I'm going to follow this up with the aggregate method. There's different ways you can use it. I like to use a dictionary inside. My cases column, I want pandas to sum them. And same for the number of deaths. I want my countries to become the index. And now that my data is aggregated, I can define a ratio, for instance, the number of cases per 1,000 individuals. It's going to be equal to 1,000 times the number of cases divided by the population of the country. Let's see what it looks like. Here is France, with the population of 67 million and 1.2 cases per 1,000 individuals. You can also sort your data in Pandas, for instance, in descending order of cases. And to do that, you need the sort values method. column I want to use is cases, and I don't want that to be ascending. So if we display the top 10 rows, we now have the top 10 countries in terms of cases. So the first 3 are the US, Spain, and Italy. We could sort it by the number of cases per 1,000 individuals too. This is what it would look like. For instance, in Andorra, you have more than 7 cases per 1,000 individuals. And you can also join, like in SQL. If you don't know SQL, joining just means combining tables together. For instance, in our clickstream data frame, there's a country ID column, and in our countries data frame, there's a column to look up that ID and get the country name. So in Excel, you'd probably do a VLOOKUP for that. And to join in Pandas, you generally use the merge function. Side note, there's also a join function, but it's actually made to join on indexes, not columns. So here we are using merge. My left table, so that's going to be clickstream. Then my right table. The column from my left table using the left-on parameter is country ID, and same on my right table. The names could be different though. And the type of join that I'm going to do here is a left join. Doesn't make much of a difference, an inner join would return the same results. It just means that I want to keep all the records from the left table, so clickstream, and wherever I can find a match, add the records from the countries table. So now you can see that we've added a column country name that corresponds to the country ID in our lookup table. 1 is the UK, 2 is France, and 3 is Sweden. Another useful SQL thing that you can replicate in Pandas, removing duplicates, i.e. select distinct in SQL. So let's consider this analytic scenario. Can you tell me what the visit conversion of our e-commerce website is? Visit conversion is the ratio of the number of purchases to the number of visits on our website. So we need 2 things, the numerator and the denominator. First, the numerator. I'm just gonna sum my purchase flag column. The denominator is a bit trickier, and that's where we'll need to deduplicate. The problem that we have is that each visitor can have 1 or more visits. So what we need to know is the distinct couple of values between cookie and visit number. I'm just going to select the subset of columns I'm interested in that instance, cookie and visit number. I'm going to use the method Droppin. Let's see what that looks like. See, I have all the unique combinations between cookie and visit number. So this guy only has 1 visit, 1 visit, 1 visit, 1 visit. This guy has 2 visits, this guy 2, and this guy 2. So we are basically just after the length of that data frame. Then our conversion, as we said, is the ratio between the number of purchases and the number of visits. And then we can display the results, the number of visits, the number of purchases, and our conversion. The answer is 20%. 10 visits, 2 purchases. You can also change the shape of your data frame using melting and pivoting, which are just 2 sides of the same thing. Changing your data frame from wide to long or long to wide. So let's build an example data frame. It's just going to be a copy of our coronavirus by country data frame. I'm just going to reset the index. Using the melt method, I can reshape the data frame from wide to long. So we need to tell Python what are the metrics, the values, versus the non-numerical columns, ID vars. So my values are here in a list, and my ID vars are just going to be country name. All of our numerical columns are now stacked on top of one another. And in Pandas, pivoting means going from long to wide. So let's create a new data frame called pivot based on our melt data frame. And we're going to call the pivot method. As index, I'm going to pass the country name. My columns are stored in the variable column. And my values in the value column. Here, back to square one. So, we are now getting to the final chapter of this Pandas tutorial. Time stuff. Exciting. The toDateTime function in Pandas is helpful to convert strings to timestamps. It's pretty cool because it's quite robust. Let's try it out. 23rd of February. But I could write 23rd of February 2020. It still works. We can also extract time elements using the string format method. .strf time. Let's say we want the year, you just write this. 2020. By changing the Y to an A, I get the day of the week, Sunday. You can also add time periods to a date, for instance. And to do that, you need the toTimeDelta function. Let's say I want to add 5 days. This is what I get, the 28th of February. So let's move on to time series. Pandas is pretty good at it too. You can see that the date column of our coronavirus data frame is not a time variable. So let's change that. Our data looks the same as before, but the date type of date has changed. You can also compute time differences in Pandas. For instance, the difference in days between the oldest and the newest date in our coronavirus data frame. And to do that, we're going to use the days attribute. What we need first is the difference between the max, the newest, and the min, the oldest. We want to express that difference in days, .days, and just to be pedantic, I'm going to add 1 at the end, because we want to count all the days in the interval. The data covers 101 days. As I was saying before, you can manipulate time series very easily in Pandas. First, let's go back to our grouped and sorted data frame at country level. If we display the top 5 index, we get the top 5 countries in terms of number of cases. The data frame country is filtered just for the US. And if we group by date, we get the daily evolution of the coronavirus cases and deaths in the US. But we could be more visual about it. And Pandas allows you to do that very easily. You just need to add .plot at the end, and you get 2 trend lines, one for cases, one for deaths in the US. Because Pandas knows that we are dealing with a time series, it doesn't overcrowd the x-axis. You only get monthly markers, although you have daily points. But we can go full Python on this. Let's say we want to see the same chart for each country in the top 5. We're going to use a for loop. You've all watched my loops video, right? And we just need to change that USA to our loop variable country. There you go. You have 5 charts of our coronavirus cases and deaths for the top 5 countries. The US at the top with the most cases, and China at the bottom, where things happened much earlier. Let's say we want to aggregate all the countries together to look at global cases over time in a new data frame. Very easy in Pandas. Let's just call that new data frame dftime, and we can plot it like we did before. So we can see, for instance, that so far the daily peak of cases is around 80,000. But let's say we're interested in the cumulative sum over time. No need to do anything fancy with loops. All you need is the cumulative sum function. So you can see, for instance, that globally we've reached 1.4 million cases. We can also focus on certain date ranges. For instance, if we just want to look at February, we do 2020, February 1st, 2, using the colon, 2020, February 29th, and we get this cumulative curve. We can do the same for March. There you go. Before we say goodbye, I have 3 useful resources to share with you. Links are in the video description. The first one is on GitHub. Like the 100 Numpy exercises, you have 100 Pandas puzzles. The second one is this section of the Pandas website. It's a great 10-minute hands-on tutorial of Pandas. And 3, Kaggle. If you're looking for datasets, you'll find plenty on Kaggle. There's a lot of stuff there, even competitions. And as a side note on the coronavirus, a lot of people in the Kaggle community are working on it. So if you want, you can contribute to the research to understand coronavirus better. Apologies for the long video again. I'll try to be more concise for our next video on visualization. Anyway, I hope you feel like you know what Pandas is and what it can do. As always, thanks for watching. Like, share, subscribe, hit the notification bell, comment to let me know what you think and would like to see next. And remember, practice makes perfect.